Welcome to the latest video looking at 3D inside Witness 14. In this particular training session we're going to be looking at the importing of shapes so you can use ones that are outside the Witness library with your models. Here we take an example model on the screen that is just a simple conveyor leading to an operation, and occasionally that operation breaks down and there is feedback onto the conveyor. So the model might be, for example, looking at the buffering capability of the conveyor with the different patterns of breakdown that exist. This particular model is one of TV production, and the machining operation is a test station. Let me do a quick 3D from the basic library, and we'll see that we've used the one of the standard conveyor displays, and we've also got a test station with a table for where the quality inspection or the testing is going to be taking place. And there is a person who is set to work on the testing when testing is needed. And if we set the model running, you'll see that the default shapes are the yellow boxes, and they're traveling along the conveyor, and after a while we get a breakdown in the operation. The operator moves away from the table and we see the queuing back on the conveyor. So that's all using the standard library elements inside Witness. But what if we wanted to have something a little bit more realistic instead of the box for our TV parts? Well, I'm going to show you now. I'm just going to open up SketchUp. This was a product developed by Google, and it's now distributed by Trimble. And this product, SketchUp, has a vast repository of shapes in it, in what's called the warehouse, the 3D warehouse. And more importantly, well, not more importantly, but equally importantly to that, all those shapes will export in the Collada format, the DAE format that is required for importing into Witness. Now, with SketchUp, the first thing we always do is to get rid of the figure which appears in the view when you first start it up. And then, in order to look for shapes, we'll go to the File menu and we'll go to the 3D warehouse. Now, obviously, you need a web connection when you call this up. And I'm just doing this live, so just waiting for this to load. And then I will type in a search term, so full HD LCD TV. Say that's what I'm looking for in this particular instance. And you'll see that there are many different 3D shapes available which are full HD LCD TVs. Let's pick this fairly simplistic one. And we can see by clicking on it, it opens up its own window and it tells us how many polygons there are, how many materials. So it gives us an idea of how complex it is. And although Witness 3D is very powerful in terms of processing geometries, it still makes a lot of sense for things which are repeated, such as parts in a model, to try and make them as reasonably simple so that you get the performance from the 3D model in terms of generating the right frames per second when we're actually running the simulation to make it smooth. So now we go to the download button and press that, and it says, do you want to load this directly into your SketchUp model? And we'll say yes, and in comes the television into the SketchUp view. Now the best thing is to kind of drop it and then use the move tool to actually adjust it along the different axes that are on display. There you see I'm dragging it along the red axis. Now when you're happy that you have it as centralized as possible, and there are tools in SketchUp to get it very accurately positioned if you want to learn what those are, then this is when we go to the File menu and use the export option for a 3D. I'm going to save into my training webinars directory a shape called television.dae, and you hit the export button here. So now we're back in the witness model. Let's change the mapping of that particular part, P1 here in this model. Let's go to Update Graphic. Let's go to 3D. And here we're seeing the yellow cube, or the yellow box, which is the default part shape. Now instead of using that default part shape, we want to import. So you need that from this top box. You do need the user-defined mapping to be selected, and then this button here is enabled. So you now import 3D shape from File, and here in my document tutorials directory I have a television.dae file. So I can just double click on that, and it loads the television into the library that can be used with Witness 3D models. Now if you notice here, I'm just moving around the view, and it came in edge towards us. Now the orientation, the default orientation for shapes in Witness is if they are facing away from you into the Z plane. So that would be a 0 degrees of rotation that we would need to put on the part, and because it's this way around, I'm going to actually put a 90 degree of rotation on the part so that it will orient the right way. The other things I'm going to do is to make the part the right size for my model. So don't forget, witness models do not have to be scaled in any particular way, but the model coordinate setting will show you what the scaling is for your particular model, the way in which it's set up, and you need to say how big the 3D parts are going to be. So you can accept the default, or you can adjust it, and I'm adjusting it in proportion here because I want it to be scaled nicely to still look like a television. And one of the nice things here is that you can actually auto scale the height, which will just work off the width and the depth fields there to set the height properly. So coming out of there and updating, we can now re-zero the model. We can quick 3D it. There's our model again, and I can set the model running, and we see now we have those TVs coming in and acting as the 3D part in our model, and we're seeing them queue back along the conveyor here. So let's have a look at another example of an imported part. Let's, instead of that part, pick something completely different. Let's this time pick a crankshaft. Now the crankshaft, if we just have a look at it, zoom into it a little bit, don't forget that you can do a Control W in the preview window here after pressing with the middle mouse button in that window, and it will go wireframe, so you can look at things in wireframe, see how complex they are that way. That looks all pretty good to me. And when it comes in, it's oriented flatly into the Z plane, which is the way I want it oriented. So this time I'm going to take the 0 off the rotation. And let's stick with the default size this time. Now you can see it's 5.35 meters or units by 1.22 by 1.21. So it's going to be pretty big inside the model. Let's just see what that looks like. So what we can do now is to update that. We can do a quick 3D. We don't have to re-zero the model, and we can see that we are completely crankshafted out in this particular model. We have very large crankshafts dominating our view, and probably we would want to do things a little bit more selectively. So let's just a little bit different sizes to that, or better sizes. So here we see the shapes arriving along the conveyor, and yes, really they are too large for this model. So you go into that dialog and you'd simply adjust the size of the model as well. Now say that you wanted to use this test frame operation here, which we've got linking into the machine icon, but you wanted to use it for something like the crankshaft, but maybe you wanted it to rest across the top of the frame rather than being anything to do with a table in the middle, maybe something completely different, but you just wanted to rest it across the frame. Well, it's perfectly possible to adjust the queuing position of the part. If I just stop the model with the part actually on the table here, how would we go about doing that? Well, we right click on the machine geometry and bring up the representation in 3D. Now you'll see that we have the test rig 3D object shown here. Now this is a library object, and we don't allow you to change the base library object, but as well as being able to adjust queuing positions of imported objects, it is possible to take a copy of a library object using the third button here above the lister, and if we take a copy of it, you'll see that the clone was successful, and we have something now which is DGIC test rig copy 1, and so it's created a copy of it, and that allows you to adjust this last button here in the buttons above this lister. This is to edit the 3D queue properties of this object, and that is for exactly the purpose of adjusting positions on parts on vehicles, of parts on carriers, and of parts when they're at machines. When we click on it, we get this view, which is a bit daunting at first. We've got some huge cubes in here. These give a lot of information about where the queue starts. The queue always starts at the center of the golden cube. The golden cube has different colored little pyramids and squares on it, which show the direction of the different orientations of the thing that you're going to represent in this queue. So because green here, the little green pyramid, is facing upwards, I know that the parts are going to be the right way up on the table, and the other orientations give you the other orientation direction for the parts which are going to appear in this queue. So if we wanted to adjust this up, we could go to the queue position here, and you notice all the different positionings here in this queue editor, and we could say let's make it 2 meters above the table. In fact, that doesn't seem to be enough, so let's go to 2.5. Let's go to 2.5. And now we're pretty well up at the level of the cage. So let's see how that would affect. Now you notice, by the way, you will notice there are queue position, queue direction, and the item rotation in the queue can all be changed in this particular dialog box. And also the alignment based on the queue positions can either be over, under, or centered on that queue position. When we're happy, we say OK. The cubes disappear and we're left with just the geometry again. Having done that, now we update, OK, and update it. And then when we quick 3D it again, you'll notice the position of the crankshaft has moved substantially upwards. And you can adjust it at will to fit the position, the exact position that you would like it to be. So hopefully that's given you a bit of insight into the ways of bringing geometries into Witness, and also how you might go about on imported geometries or copies of library objects, adjusting the queuing positions where parts would appear when they're at the particular element. Just like to give you a little bit more information about where the imported assets are stored for Witness, imported geometries, or indeed imported materials which you might bring in to apply to extrusions. But all the shapes are stored when you import them into a special directory, and this is by default in C, Users, Public Documents, Lana Group, Witness 14, W3D, Imported Assets, and the shapes, the geometries, are all placed in the Shapes directory. So here we look at the television that we brought in. That will have its own directory in that particular file structure. And inside that directory we have these 5 files here, one of which is the DAE shape, the Collada file format. There are 3 image files which will automatically be stored in this area, which apply to that television. And in addition, there is a shape.xml. If we just edit that with Notepad+, we can look and see what's in there. And there's certain things about the different versions of and encodings in XML. There's a unique ID that's assigned to it for use inside the program, and a name. And then all the queuing positions that I showed you before, the part, role, pitch, yaw, the different positionings and whatever, they're stored inside this XML file. And then we have the localization in the different languages for the name that might be used, might be different in the different language versions of Witness that are used, and therefore they can be adjusted here for each language as necessary. So it's just some simple information held in the shape.xml file, but the key one is the DAE file. That's where a copy of whatever you've imported will be kept in Witness. If ever you send a model where you've imported a shape to another user, you must also either send them the shape and tell them to import it, or you can just copy this directory and they can copy and paste the directory into their shapes directory. And if there's a whole load of different shapes, it's a very efficient and quick and easy way of doing swapping over the 3D geometries, just copying all the directories of the shapes which have been used. And then if your colleague puts them in this directory, in the imported asset shapes directory, they don't need to do the import inside Witness, because the shapes will already be there and residing in the right directory. So there we have it. That's the end of this particular tutorial. In one of the subsequent tutorials we'll be looking at another model with a lot of imported shapes in detail. So until then, thank you. Bye bye.